Hello everyone, welcome to you. And now I'm going to start lecture number 4 of this video lecture series, Basic Mechanical Engineering Unit 3. And this is a series actually based on IC engine. So this is fourth lecture, okay? So first of all, let me tell you what is two-stroke engine and what is four-stroke engine and what is the difference between them, okay? So in the previous lecture, we have seen about four-stroke engine, is it right? So before going to start a complete discussion about two-stroke engine, let's see the difference first, okay? So, and even I'm just going to recall this four-stroke engine, and then I will tell you the two-stroke engine, okay? So basically this four-stroke engine works on a thermodynamic cycle, is it right? And this thermodynamic cycle includes four processes in which we have first process, that is suction. Second process is compression. Third process is expansion. And the fourth process is exhaust, or you can say exhaust stroke. Is it right? So these four things is happening in the four stroke engine. So if I talk about the cylinder and piston arrangement for each stroke, then you can say this is a this is a cylinder and this is a piston which is located at the top dead center. Is it right? And in this condition, the connecting rod and the crankshaft both are collinear. Okay, and in this, the inlet valve is open, exhaust valve is closed. Okay, and your piston is approaching towards BDC from TDC. Is it right? From TDC to BDC. Correct. So this is our first process. In this, suction takes place. Is it right? So I'm just writing number. And in the next one, you can say here. And you can also see one more thing. In this, we have valves. Okay, inlet valve and outlet valve. And now when your piston is positioned somewhere here at the bottom, that is called BDC. And in this condition, you can say the piston and crank, you can say both are you can say overlap to each other. Is it right? And remember, this is a crankshaft. Are you getting my point? This is a crankshaft. And in this is a crank, sorry, this is not a crankshaft. Here we have a crankshaft. This is a crankshaft. Okay. So here we have a crankshaft in which crank and connecting rod both overlap. And now your piston is approaching from BDC to TDC, and both valve get closed, that is inlet valve closed and exhaust valve also closed. And now when your piston is moving up, then whatever combustible fluid we have inside, it get compressed. Okay, and this is called actually compression stroke. That's why this is called compression stroke. Are you getting this? So you can see in this stroke, obviously when piston is moving from TDC to BDC, then this crank can rotate by an angle theta is equal to 180 degree. Ideally I am telling you, okay. And similarly, when your piston is approaching from BDC to TDC, again the crank will rotate by 180 degree. Is it right? So you can see here in one revolution, obviously we have 360 degree. So in 360 degree, the piston can reciprocate from TDC to BDC. Is it right? Then BDC to TDC. Correct? piston can reciprocate like this from TDC to BDC and from BDC to TDC. Is it right? It means when piston can reciprocate from TDC to BDC and then BDC to TDC, then at that time the crank can rotate by 360 degree. Is it right? 180 degree for one stroke and 180 degree for another stroke. So here we have two strokes which will be completed in one complete revolution. Is it right? Are you getting this? For completion of in one revolution of the crank, one revolution of the crank means when this crank can rotate by 180 degree, you can say, if I draw its locus, then it will be drawn like this. Means after, in one revolution of the crank, one revolution, complete revolution of the crank, we will get two stroke. Is it right? And now again, your piston is positioned here at the top dead center. And again, here you can see both connecting rod and crankshaft are aligned together collinearly. And here again the valve, both valve get closed, inlet and outlet valve closed. But at that time, with the help of a spark plug, we just produce a spark so that the fuel get burned. Is it right? And obviously if it get burned, then huge pressure may arises, and because of that the piston can further move from TDC to BDC. Is it right? Correct? So this is called actually expansion stroke. Again we can say here, then again crank can rotate by 180 degree, means 1.5 revolution of the crank is completed till now. And this is actually power stroke. This is a only power stroke. Is it right? Means here we will get power from the this reciprocating system. The rest in the in all the operations we will provide power externally. Is it right? And once the expansion completed, means piston reaches from TDC to BDC, then again it starts moving in the upward direction from BDC to TDC. Is it right? Then again it will in this condition crank will rotate at 180 degree, and this is step 4. Is it right? This is stroke number 4. Correct? So you can say this is a suction stroke, this is a compression stroke, this is power stroke or expansion stroke, and this is exhaust stroke. Is it right? So these four processes may happens, and in that condition simply you can say the inlet valve is closed and exhaust valve is open now, so that the all combustible fluid can move away from the piston cylinder arrangement. Yes or no? So this is called 4-stroke engine. Is it right? But you can see here in 4-stroke engine, here we will get two complete rotation, 180 degree here, 180 here, 180 here, and 180 here. Is it right? So in the second revolution again we will get two strokes. Is it right? So you can see in the first revolution in the first revolution we will get suction stroke and compression stroke. Is it right? And in the second revolution of the crank we will get expansion stroke and exhaust stroke. Means for completion of one power cycle, two revolution of crankshaft required. Two revolution of crankshaft required. Is it right? Two revolution of the crankshaft is required for completion of one power stroke or one power cycle. Two revolution of the crankshaft required, means in every two revolution of the crankshaft we will get one power stroke. Are you getting my point? Now the question is, since you will get power in only in this stroke, third stroke, that is power stroke, then how this engine receives power for operating in remaining three strokes? Then the answer is for this. Basically, along with this engine, we always provide a flywheel, and its purpose is to store energy when power is produced during power stroke. Is that right? And that energy is further utilized for running this piston cylinder arrangement in remaining three strokes. Is it right? So remember, in four stroke engine we need a heavy flywheel. So if you have seen any DC generator, any you can say uh, diesel pump set or any engine, then you have seen a big size wheel which is connected with the crankshaft. Is that right? So the purpose of that wheel is to store kinetic energy. Is that right? And once it gets stored, then because of that inertia, the rest, that energy is delivered for the suction stroke, for the compression stroke, for the exhaust stroke to reciprocate the you can say piston inside the cylinder. Is it right? So this is the one of the drawback of this four stroke engine. Is that right? Although in the four stroke engine, since power is produced in only one stroke, so for the heat removal from the from the cylinder receives more time, then that's why here we will get more thermal efficiency. Is it right? And of course here we have more compression ratio, that's why we also have more thermal efficiency. Correct? But here we have one drawback, that is in two revolution of the crank only one power stroke we will get. Is it right? Correct? Now for this drawback, for overcoming this drawback, one inventor that is named as Douglas Clark, he developed, he was developed two stroke engine which produces power in every revolution of the crankshaft. Are you getting my point? In the four stroke engine, since it will produces power in two revolution of the crankshaft, is it right? So this is one of the drawback of four stroke engine, because of that it needs bigger size flywheel and less power it will produce. Is it right? To overcome this issue, Clark will develop, Clark was developed or invented two-stroke engine which produces power in every stroke. Is that right? So this is one of the biggest advantage of this two-stroke engine. It will produces power in every stroke. You can see in two-stroke engine, the cycle is completed in one revolution. Is it right? Of the crankshaft. This is the very important development of IC engine. Is it right? In this two-stroke engine, in every revolution of the crank we will get power. Is it right? So I hope you will understand, and rest of the information, if you're interested, then you can read it. Is it right? I'm not reading here, I'm just highlighting the important point and the reason behind the development of two-stroke engine. Is it right? So now you can see the operation, how two-stroke engine works. So this is a two-stroke spark ignition engine, means petrol engine. Is it right? So you can see here in this engine, you can see in the stationary condition, you can see here, this is a piston. This is a piston. Is it right? And you can see the design of piston is different. In the four-stroke engine, basically, we have seen flat engine, sorry, flat piston like this. And of course, in this piston, we have a piston ring like this. We have a piston ring. So this types of piston basically we saw in the four-stroke engine. Is it right? Flat piston. Is it right? Flat piston. Correct. But you can see in this, we have a piston which is made like this. Is it right? It has some curvature. And why we provide this curvature, I will tell you in the later on discussion. Okay. So now you can see, understand, this is a piston. Is it right? And of course you can see here, this is a spark plug. This is a spark plug. I'm not writing its full form, you know very well. Spark plug. Is it right? And this is the only valve which is provided in the engine. So this is called inlet valve. Is it right? and this is a especially spring loaded inlet valve. Is it right? Inlet valve. Is it right? This is the only valve which is provided in the two-stroke engine. Otherwise, you can say in the four-stroke engine we have two valves, inlet valve and exhaust valve. But in this we have only one valve, that is inlet valve. Is it right? And next you can see here, this is a connecting rod. This is crank. Is it right? And of course, this is a crankshaft. In short name, I am writing here. Yes or no? And this is not a valve. This is just a opening which allow to escape the burn fuel. Means exhaust. So simply you can say this is called exhaust port. Is it right? This is called exhaust port. So this is exhaust port. And similarly, you can see here uh, one more information I'm telling you here. You can say this is the space from which the charge or air fuel mixture can enter into the cylinder. So this is called transfer port. Is it right? Transfer port. This is called transfer port. So you can say this is an exhaust port, and this is transfer port, and this is the only valve which is provided here, that is called spring loaded valve, inlet valve. Is it right? Inlet valve. Are you getting this? And rest you know, the piston, the connecting rod, the crank, the crankshaft, the cylinder, etc. Yes or no? Correct? So I hope you will understand what are the important parts of IC engine. So now the question is, you always face how to draw this figure. Sir, in the exam, the question may ask, draw a two-stroke engine and explain all the important parts of the two-stroke engine. Is that right? So now I'm just telling you how to draw this figure freehand. Is it right? In especially in your exam. So you can see here, you simply construct like this figure. Is that right? This is outer structure of this engine, two-stroke engine. Yes or no? And obviously here you just provide a spring-loaded valve. This is spring-loaded valve, and of course in this you also provide here, this is a port actually. You can see this opening actually, this opening. Okay, this is a actually opening here, and we have a piston which has crown actually. This is called crown. Okay, this is called a crown. And this is connecting rod, and this is a crank. So like this you can construct a two-stroke engine. Is it right? And of course here we have a spark plug. This is the exhaust port. Of course, this is a spring loaded valve. Inlet valve. Is it right? Actually, this is called crank casing. This is crankshaft. And this is actually a crank. This is crank. This is connecting rod. Is it right? So like this, you can construct a two-stroke engine. Are you getting this? Like this, you can construct a two-stroke engine. And these are the important parts of two-stroke engine. Is it right? Yes, now it is visual, I think. Okay. Correct? So basically, you can construct two-stroke engine like this. Now let's see how it works. Okay. So now you can say, uh, yes. So this is a condition. This is a condition in which this inlet valve is closed. Is it right? Inlet valve is closed. So now, and your piston is positioned at the BDC, yes or no? Simply can I say this is a location, this is called a BDC position, yes or no? Piston is located at BDC. And now, now when your piston is, yes, at this condition, you can say, is that right? So when your piston is approaching towards TDC, so you can see this figure here. You can see this figure. So I think you understand the elements component name of this two-stroke engine. So I'm just removing this so that we can easily understand this figure. So you can just understand. Okay. So you can see here your piston is approaching from BDC to TDC. Yes or no? Your piston is moving up. So already you can see here we have a charge. This is a charge. Why I'm telling you this is a charge? Because this is a mixture of air and fuel. So you can see when your piston is moving from BDC to TDC, then here two processes simultaneously going on. Is it right? Two simultaneous processes already going on. How? So you can see this valve is open at this state. You can see this inlet valve is open. You can see here this inlet valve is open here, and because of that the fresh charge is entering into this area. Is that right? The fresh charge is entering into in this area. So this is called suction or intake stroke, which is already going on here. Is that right? And along with this suction stroke, since here we have here we already have some charge. Is that right? Means fresh charge is entering here and it contains already some unburned charge. Yes or no? And because of this movement of piston from BDC to TDC, this already filled charge get compressed. Is it right? Already this filled charge get compressed. Okay. So in one stroke, when piston is moving from BDC to TDC, then two simultaneous process is going on. Is it right? One is suction, and another is, this is called compression. Is it right? So are you getting this? Are you getting this? Let me tell you, if I just take this figure outside. So you can see here in this figure, if you see in a very carefully, then you can see, hmm, now it is clearly visible. Okay. So when your piston is approaching from BDC to TDC, is it right? Then at that condition, you can say this valve get closed sorry, this port get closed, exhaust valve, sorry, exhaust port closed. EPC means this is exhaust port closed, yes or no? And this is inlet valve, so this is inlet valve open. IVO means inlet valve is open, and this is a transfer port. In short, if I write, this is transfer port. Transfer port get closed. Transfer port get closed. Are you getting this? So at this stage, when piston is approaching from BDC to TDC, these three things is happening here. Okay, exhaust port is closed, inlet valve is open, and transfer port is get closed. Okay, and rest, obviously the fresh charge is coming inside this crank area, and already which is some charge is available here in the piston cylinder arrangement. So this charge get compressed. Okay, so it means during this process, during this is stroke 1, is it right? this is this is stroke 1. Are you getting this? This is, let's say, stroke 1, in which crank will rotate with 180-degree, and due to this rotation, here we have uh inlet, or you can say suction stroke, and another one is compression stroke. Both process is happening simultaneously. Are you getting this? Are you getting this? Next, once, yes, once this charge get compressed at this stage, is it right? Now you can see at this location, the complete fresh charge enter into the cylinder, and this piston is reaches to TDC, from BDC to TDC, and the whatever charge we have inside it, it get compressed. Now it is ready to spark or ready to burn, is it right? So at this stage, when piston is located at the top dead center, then with the help of this spark plug, you just provide a spark so that this fuel get burned, is that right? And because of this burning of the fuel, obviously huge pressure suddenly rises, and hence this piston moves. Because of that pressure, this piston moves from BDC TDC to BDC, is it right? This piston moves from TDC to BDC. So at this stage you can say, if I tell you in the details, at this stage you can say, when your piston is moving from when your piston is moving from TDC to BDC, is it right? Then you, at that stage, you can say here, at this stage, especially when your piston is located somewhere here, so whatever charge we have inside it, it get burned, and after burning, this piston starts moving down from TDC to BDC. Then this is stroke number 2. This is stroke number 2, and of course here we don't have any space, so I'm just writing this explanation in the next slide. Okay, okay, so you can see here. So this is stroke number 2, in which piston is moving from TDC to BDC. Again, can I say the crank will rotate with 180-degree, is it right? And at that stage, what is happening here? So you can see this valve get closed, so inlet valve closed. So I'm in short, I'm writing here, inlet valve get closed. This is exhaust valve is also closed, sorry, exhaust port is also closed. Exhaust port is also closed, is it right? And similarly, this is transfer port, so transfer port is also closed. transfer port is also closed. Is it right? So in that condition, this burned get expand, expansion takes place. Expansion, expansion takes place. Is it right? So in this second stroke, we will get first, third process, that is expansion. Yes or no? But once the piston reaches below this, below this uh, exhaust port, exhaust port, and at that condition, you can say here, you can say yes. At that condition, when piston reaches at the BDC, then again this port get open. Is it right? This port, inlet transfer port get open, and this exhaust port will also open. So since here the fresh charge is again entering into the cylinder, and because of that pressure, the exhaust gases may escape from the exhaust port. Is it right? And this is happening in the second stroke itself. Is that right? So you can see this figure. You can see this figure. Are you getting this? And this is stroke number 2. This process is already happening in the stroke number 2 when piston is moving from BDC to TDC. Yes or no? Sorry, TDC to BDC. Here the piston is approaching from TDC to BDC. But when the piston reaches at this location, then obviously this valve get already closed. Inlet valve is already closed, but this transfer port get open. Transferred port get open, and this exhaust port get also open. So here TPO is a transfer port open. Yes or no? Exhaust port open, and inlet valve closed. Okay, and this is already happening in this second stroke. Remember, this is already happening, this process is happening simultaneously in second stroke when piston is moving from TDC to BDC. Means this piston is moving down, and when it reaches to this point, then at this point you can see this figure. Corresponding to this point, you can see this figure in which this transport port get open, exhaust port get open. So because since this fresh charge is entering into the cylinder, and it applies some pressure, and because of that pressure the exhaust get escaped. Is it right? Exhaust get gas get escaped. So simply can I say, in this second stroke, along with this expansion, exhaust is also processed. Okay, exhaust stroke is also completed. Yes or no? Simultaneously. Is it right? Completed. So obviously for completion of one thermodynamic cycle, we need suction, compression, expansion and exhaust. And all these things happen in the only two strokes. Yes or no? Is it right? Only two stroke. Are you getting this? In one stroke, stroke number 1, suction and compression both completed. And in the stroke number 2, expansion and exhaust will completed. Is it right? So now thermodynamic cycle is over now. So simply can I say here, from this working we can understand, for completion of one power cycle we need only one stroke. Is it right? So this is the working principle of two-stroke engine. So I hope you will understand what is two-stroke engine, and you can see this figure at a different location. Yes or no? And with this animated video, you can understand how two-stroke engine works. Yes or no? Okay, so I hope you will understand why two-stroke engine we need to develop, and how it works, how to construct in your exam. Is it right? And you can see this is a PV diagram, ideal PV diagram for this spark ignition two-stroke engine. Is it right? So 1 to 2 actually it is nothing but this represents, you can say, this 1 to 2 process represents compression, 2 to 3 process represent combustion. Is it right? And 3 to 4, 3 to 4, here we have two process, 3 to 5 and 5 to 4. Is it right? 3 to 5 and 5 to 4. 3 to 5 and 5 to 4. Here we have two process. Is it right? That is expansion along with exhaust. Is it right? So basically in thermodynamic cycle, if I say, so this is heat addition. Is it right? This process 1 to 2 is called as sorry. Okay, I'm writing here again. So 1 to 2 process, actually here isentropic compression takes place. Okay, isentropic compression. Is it right? Isentropic compression process. This is named as isentropic compression process. And 2 to 3 is heat addition. Constant pressure, constant, yeah, it is also called as isobaric heat addition. Is it right? Isobaric heat addition. And 3 to 4 is isentropic expansion. Is it right? And in this isentropic expansion, actually we will get work, mechanical work, okay, or we can say power. And 4 to 1 is isobaric heat rejection. Is it right? So see, in this video lecture series, actually I am giving you a knowledge up to the first year level. Is it right? I'm not telling you information in a very detail. Is it right? And if you're interested, then its video is already available in applied thermodynamics section. Is it right? So in detail basic thermodynamics of this process is already explained. Okay, so I'm just telling you on up to a UG level, sorry, up to a first year level knowledge. Is it right? I'm not telling you in the all the information in very details. Is it right? So these four processes are happen in this two-stroke engine. Is it right? So you can see here we have another process that is called scavenging process. So what is this scavenging process? So at this stage you can see here. I'm just, yes, you can see this at this stage. This transfer port is open, exhaust port is open, fresh charge is entering here, or burnt charge is moving away. Okay, so sometimes what is happening here, some fresh charge also move away from this exhaust port. Is it right? Along with this burnt charge, some fresh charge move away, some fresh charge move away from the exhaust port. So this removal of fresh charge from the exhaust port is called as scavenging process. Is it right? Removal of this fresh charge, removal of this fresh charge, yes, in this I'm just explaining you, you just see here, you just correlate both the figures. You can say at this stage, can I say here, this transfer port is open, this transfer port is open, this exhaust port is open, fresh charge is entering into the cylinder, burnt charge is escaping from the cylinder. Is it right? So sometimes this fresh charge can also escape along with the burnt charge. So this process is called as scavenging, and this is one of the major drawback of two-stroke engine. Are you getting my point? This is the only major drawback of this two-stroke engine, in which fresh charge can also move away from the exhaust port, yes or no, along with burnt gases. Means here we will get less fuel economy, it will get less mileage. Is it right? That's why in the modern automobile we always see four-stroke engine, because entire fuel can be utilized for producing power. Yes or no? But in two-stroke engine, fresh charge will also escape along with burnt charge. So here we have more wastage of fresh charge. That's why it will gives us less mileage, less fuel economy. That's why these engines are obsolete nowadays. We are not using. We have very limited application of two-stroke engine. Is it right? Otherwise, nowadays we are completely eliminating this two-stroke engine. We only using four-stroke engine. Otherwise, for two-stroke engine gives us power in every strokes. So whenever we need very huge power, then we use two-stroke engine. Like for the starting of very large ship vessels, we need two-stroke engine. Are you getting my point? For starting of मतलब अगर आपको शिप को रन करना हो, स्टार्ट करना हो, then for the starting of this ship we need a two stroke engine. Is it right? Because in the ships we have very big size propeller, big size engine, and it cannot operate it directly. Is it right? So for the starting initial, for giving initial torque, we use two stroke engine. Are you getting this? And why we use two stroke engine? Because its construction is light, it will produce power in every stroke, so it will produce overall very big power. Yes or no? Is it right? But yes, you have seen here we have drawback, that is fresh charge can move away from the piston cylinder arrangement without combustion. So obviously we just throwing some fresh charge away from the cylinder. So this is called scavenging process, and this is one of the major drawback of two-stroke engine. Is it right? And of course you can see, since here the construction of the engine is small, is it right? And there is only one valve we have, so its operation is also easy, wear and tear is also very less. Is it right? Still it is not using because of wastage of fuel. Is it right? Correct. So this is all about two-stroke engine and four-stroke engine, and every information is given here. If you interested, then you just read it. Okay. And these strokes, and yes, this is not required. Okay, so let's see another important point, that is difference between two-stroke engine and four-stroke engine. Is it right? So in two-stroke engine, you can see in one revolution of the crank shaft, we will get one power stroke. Is it right? And every revolution of the crankshaft will get power stroke. But in four-stroke engine, in two revolution, we will get two revolution of the crankshaft, we will get power stroke. Okay, it generates high torque, it generates less torque, obviously, because in every revolution we have power, and it uses port for the fuel outlet and inlet, and it uses valve. Is it right? In this we use port, and in this use valve, and its engine result in lesser thermal efficiency, and it gives us higher thermal efficiency. Why lesser thermal efficiency? Because must few amount of fuel some amount of fuel may escape away from the engine without burning. Is it right? It generate more smoke, so less efficiency, and obviously it generate less smoke and more efficiency. Is it right? And this is the major reason behind the use of four stroke engine. And it requires lubricating oil. Why it is required lubricating oil? Because you can see the fuel also mix with this lubricating oil, which is provided in the crankshaft, crankcase. Is it right? That's why you have seen in the two-stroke engine, whenever we in old bikes which is run by the two-stroke engine, along with petrol we always put some 2T oil. Is it right? That the purpose of that oil is because in this oil is continuously consuming. But in four stroke engine, since fuel get cannot mix with the lubricating oil, so less amount of lubricating oil is required, and frequent filling with petrol is not required. Okay. Next, it required less lubricating oil. Obviously, engines are cheaper and simple to manufacture, and here engines are expensive, and due to lubrication and valves are tough to manufacture. Is it right? Obviously it is complicated manufacturing and more number of components required, so its weight is high, so we will get heavy four stroke engine. Is it right? And engines are basically lighter and noisier, but here it is heavier, and their flywheel is heavy and less noisy. Is it right? So this is the basic difference between two stroke and four stroke engine. Okay. And let's see some more important terminology, that is some performance parameter of IC engine. So you can see here we have various various performance parameter. So obviously, as you know that in the IC engine, the chemical energy will be initially converted into heat energy, and this heat energy is further utilized to produce mechanical work. Is it right? Correct? So in every conversion, some amount of energy is always wasted. So we need to counter these losses in terms of efficiency. Is that right? So here we have first, you can see this figure. This is very important, and from this figure you can understand each and everything. So when you burn the fuel, then it will produces some energy. Is that right? Then how we will calculate this energy? So simply, this is chemical energy, and which is nothing but this is mass of flow rate of fuel into their calorific value. CV is a calorific value. You can see here, it is written here. Calorific value is defined as the amount of heat energy released during complete combustion of unit mass of fuel. Means if you have a 1 kg of coal, and if you completely burn that coal, then how much energy is it releases, that is called as calorific value. So every fuel has their calorific value. Is it right? So if you multiply calorific value with mass flow rate, then you will get the total energy liberated. Is it right? By burning of fuel. Is it right? Correct? And out of this fuel, some of the energy get wasted. Means you just see, if you have bike, then you just touch the bike engine, then you feel it get heated. And obviously if you feel the exhaust gas, then it is also heated gas. Okay, it means a huge amount of heat is liberated, removed from the engine directly, and with the help of some exhaust gas. Yes or no? So huge amount of energy get wasted, and rest of the energy we will get, then that is called as indicated power. Indicated power. So indicated power means, you can see here, you can see here. So if you have a piston cylinder arrangement like this, is it right? And initially your piston is situated here, and here you have a fuel air mixture, and when you ignite, then due to the combustion, here we will get energy, that is m dot f into cv. Is it right? And because of this combustion, this piston is moving down from TDC to BDC, from TDC to BDC. So due to the movement of this piston from TDC to BDC, whatever energy is produced by the reciprocating of this piston, so this is called as, whatever energy is produced due to the reciprocating of this piston from TDC to BDC is called as indicated power. Is it right? This is called as indicated power. Indicated power. Is it right? So are you getting this? And basically this indicated power is determined by using PV diagram. This power is actually determined by using PV diagram. If I draw the Otto cycle, is it right? Then we have Otto cycle like this. This is process 1, 2, 3, 4. So whatever area we have this PV diagram, this gives us net work done, and this net work done is nothing but this is called indicated power. Is it right? So are you getting this? What is indicated power? So indicated power is a power produced while expansion stroke when piston is moving from TDC to BDC. So during this reciprocating motion, whatever energy is produced, that is called as indicated power. Is it right? And of course some amount of energy get lost. Okay, and of course this piston cylinder arrangement is also connected with this crank. Is that right? And connecting rod. So due to this reciprocating motion, the crank will receive some energy and it transferred to the shaft. This is crankshaft. This is crankshaft. Is it right? And this is connecting rod. Connecting rod. And this is crank. Is it right? So whatever energy is stored in the crankshaft, is it right? By the reciprocating motion of this piston, how much rotation of the crankshaft takes place? So whatever energy received by the crank, energy received by the crank is called as brake power. Is it right? This is called as brake power. Are you getting my point? This is called as brake power. It is named as BP, brake power. Is it right? So, whatever energy received by the piston, energy received or energy generated by the piston reciprocating motion, that is called as indicated power. Is it right? And whatever energy received in the crank, because this crankshaft rotation will provide power to the rotation of the vehicle wheel, yes or no? And by rotation of this crankshaft the vehicle can run. Is it right? So that's why I'm saying you how much energy is received by the crank, that is called as brake power. So now you can easily understand. So this is the energy produced by the combustion of the fuel, and this is the energy produced in the piston cylinder by the reciprocating of piston, and this is the energy which is received in the crank. Okay, so this much amount of energy get wasted, this much amount of energy get wasted in terms of heat release into the atmosphere directly from the piston cylinder arrangement and by the exhaust gas, yes or no? And this much of energy is wasted due to the friction, because in the piston cylinder arrangement here we have friction surface, here we have a friction surface, here we have a friction surface. So everywhere friction losses may take place, yes or no? So this is the energy get wasted in terms of friction loss, yes or no? Is it right? So this is called brake power, this is called indicator power, and this is called energy produced by the engine. So in between them, here we will get indicated thermal efficiency. So indicated thermal efficiency is nothing but this is indicated power, means area of this PV diagram divided by the total energy supplied by the fuel. And how to calculate this total energy supplied by the fuel? Then of course this is called as indicated power divided by MF, that is mass flow rate of fuel, into CV, their calorific value. Is it right? So from this relation you can find out the indicated thermal efficiency. Are you getting this? Simply you can consider, say here in this slide, here the fuel get burned, then some amount of energy get released, yes or no? So this is the actual energy supplied by the combustion of the fuel, and due to this fuel this piston can reciprocate, yes or no? So obviously during this expansion of gas, some of the energy is directly escaped from the engine, is it right? And some of the gas escaped by the exhaust, yes or no? So obviously some amount of energy get lost from the engine, so only partial energy is utilized. Okay, so if I write the what is the efficiency of this energy conversion, then this is represented by indicated thermal efficiency. So we can write it is the ratio of indicated power over energy supplied by the combustion of the fuel, that is MF into CV, yes or no? And next you can see brake thermal efficiency. First you see brake thermal efficiency and then mechanical efficiency. So brake thermal efficiency is nothing but this is brake power divided by the amount of energy produced. Is it right? This is called brake thermal, means you can see here you generate energy and here you received energy. So in between this energy generation and receiving this energy at the crankshaft, how much efficiency we have, our system gives how much efficiency, is it right? So simply it is represented by brake power efficiency. So simply we have brake power divided by mass flow rate of fuel into calorific value, that is CV. Is it right? So like this you can calculate the brake thermal efficiency. And once you know the brake thermal efficiency and indicated thermal efficiency, then another we have very important terminology, that is mechanical efficiency. And the mechanical efficiency is nothing but obviously you can say in this piston cylinder arrangement, by the reciprocating motion of the piston, here we will get a rotatory motion in the crankshaft, yes or no? So this is a mechanical energy, this is also a mechanical energy, is it right? So by this energy, this is the energy directly received from the combustion of the fuel. So whatever energy available here and whatever energy is uh, transferred from here to here. So in between, obviously some amount of energy get lost. So we need to find out what is the efficiency of energy transfer from this piston reciprocating motion to crank rotation. So this efficiency is represented by mechanical efficiency. So that's why it is named as, it is the ratio of brake power over indicated power. So actually this amount of energy is received in the piston, sorry, in the crankshaft, and indicated power is the energy received in the piston cylinder. Okay, so this ratio is called as mechanical efficiency. Okay, and next another terminology we have, that is specific fuel consumption. Then specific fuel consumption is nothing but it tells us for generation of 1 kilowatt energy, how much fuel or 1 kilojoule, if I represent in joule, for 1 kilojoule energy, how much fuel is required. Is it right? That is mf in kg. So for generation of 1 kilojoule, if you want 1 kilojoule energy, then how much kg of fuel is actually supplied? So this is called specific fuel consumption. Specific fuel consumption. So generally it is represented by 1 kilowatt hour. Is it right? It is represented by 1 kilowatt hour, means 1 kilowatt power supply in within 1 hour. How much fuel supply is required? Is it right? So this is called specific fuel consumption. So you can see here, this is a specific fuel consumption, and this is indicated specific fuel consumption. So simply fuel consumption per divided by indicated power, and this is brake specific consumption. So this much detailed information is not required. Is it right? And yes, this is also not required. So now I think this is enough for today's lecture. And overall, according to the basic mechanical engineering syllabus, 90% part I have covered, okay, from unit number 3. So I hope you will enjoy this session. Thank you for watching and good day to all of you guys.